great. So I will start by saying I have a lot of slides here. I don't intend to talk to most of them. They're about me sort of proving that I did my homework. And that's as much for me as for everybody else. A lot of this was taking some thoughts and theories that I had and trying to prove them out or disprove them. And this came sort of again out of some of that work Nick was talking about getting ready for the Hyku camp and teaching folks about how to use Bulkrax and what does that look like. But during that process, also, we had a client who had an issue with some really weird indexing going on that sometimes things indexed as one kind of work. It was actually file sets versus Hyku file sets or Hyrax file sets. Sometimes they indexed as the other thing, and depending on what they indexed as, controlled what other jobs ran and controlled actually whether they were getting thumbnails or not. It sounds like other folks are seeing similar kinds of problems with, gee, we're not seeing the results of import jobs running the way we expected. Um, and we're not able to consistently repeat these processes. Um, so this has come up in community chats. Nick reached out to me a little bit about what I was seeing with my client. And so Connect coming up was a good excuse to do a little deeper dive in this. Based on some work that DCE did probably back in 2021, we had some suspicion that jobs weren't being run in the anticipated order, that it's hard to see this in the test suite because you really need large scale imports to be going on to start having enough load to see the problems that you have, and that it's hard to recreate some of the issues we were seeing because you really need a system where other kinds of load are going on at the same time. So other things are hitting the database. There's some interactive users going on and some interactive updates going on along with the same time you're doing large background jobs. So all of those things complicate debugging and thinking about these kinds of issues. Um, so my test bench was to run a knapsack-based application with Benchrax, or with called Benchrax with Bulkrax. You get why the names are like one another. All of this is done with a fairly recent candidate with Hyku 6.2 release candidate 4, so hot off the presses. I think a lot of the findings, though, probably point backwards to other versions of Hyku and other versions of Hyrax. And everything was done in a local Dockerized environment and a development environment. So those caveats need to be thought about of, right, there isn't other things going on in my testing. So the test plan was to get enough items that I thought would have an impact. So I took 100 items from the Federal Reserve Minneapolis has a research database repository, which is largely PDF based. Scholarly research looks like a lot of other IR kinds of repositories. The nice thing about Hyku and Docker is that we could just bring the environment down and wipe out all the data from past tests. So each time we're building a clean environment and rerunning the test with whatever code changes. We're using the Hyku dashboard, and the things we were measuring were the time it took to run the job and how many jobs actually ran. I also thought from previous testing that we'd see lots of retries of little quick jobs. Turns out not to be an issue in our environments, and I'll talk about that in a minute. So here's the sample CSV that I used. Again, it's a bunch of economic research data from the Federal Reserve. Here's the importer. It's just the vanilla importer that you see in any modern Hyku application. There was a lot of pre-analysis in terms of doing lots of single item test runs and thinking about what the process is, and then trying to sketch the process flow, setting up the test environment, then running my baseline, and then running my environment, my intervention, which I've done enough times now to be pretty sure that it's all repeatable. So a single item in a vanilla environment, I see these jobs running, and that was sort of my baseline for what's going on and how do I map this. The first first roadblock that I ran into is that it's really, really hard to sort out the process flow here because this is 3 different code bases, Bulkrax, Hyku, and Hyrax, that have all evolved over time and that have all kinds of different ways of making inter-object calls. So it was hard to think about, that. It was hard to search the code. It was hard to use tools that are usually good at searching the code for figuring out how this worked. Here's what I found in my best mental map of what's going on is the UI imports controller, when I hit submit, calls the Bulkrax import job. Anytime you see a job that's actually saving the data at that moment in time to disk, putting it in the job queue, and then waiting for the job queue scheduler to find that and pick it up and reload it later. That runs the application parser. The application parser parses through your CSV file, makes a bunch of Valkyrie ingest jobs. The Valkyrie ingest jobs call a bunch of Valkyrie uploads and create your files. Then there's an entirely different communication mechanism using a publication subscription model that we have listeners for that then listen. When they hear an event, they then create a job that gets persisted to disk. That job waits for the scheduler. That job calls characterization. Characterization then publishes an event about that things have been characterized. We get file listeners. The file listeners again hear that there's a new file that they can create derivatives on, and those happen. So again, lots of different ways of things calling other things that make it hard to reason about what was going on. The second surprise is that even with all of this in my testing, the vanilla Hyku test went very cleanly, ran with no errors, no reruns, no nothing. So kudos to Hyku for having sorted this out in their base environment. Again, the one caveat is that this is still a development environment. There's no other things hitting the database. There's no interactive users. There's no requests going on. There's no queries. One of the ways that Hyku manages to do this is by giving each job a priority. However, one of the things I discovered, and I think one of the things that's causing problems for Hyku users, is not every job that gets run is represented in this list. So we have create derivatives jobs and characterize job in this list, but those are the old Fedora-based jobs, not the new Valkyrie Postgres-based jobs. So there's a similar job with a slightly different name that's actually getting run. So we see Valkyrie characterization job and Valkyrie create derivatives instead of create derivatives job and characterize job. So not having every job that actually gets run in this list might be an issue. So with all that in mind, I ran the basic test of 100 items. In a vanilla configuration with me not having made any code changes, it takes 28 minutes. The other thing to notice is that there's a fairly high level of disk activity. So we've written 639 megabytes. In looking at all that code calling, what I realized is what I really wanted to do is just stop calling other background jobs when I was already running in the background. There was no reason to save something off to disk and run it later if I was already running it later. So we just overwrote the perform now for all application jobs if we were in the background, and that was based on looking at whether we were running. This is basically our test is good job CLI running within EXE. That means we're in the worker. With that intervention, we get down to 13 minutes, so about half the time. And I've had results that even looked a little faster than this, but normally 50 to a half to a third the time. Also less disk access. So yeah, here's earlier runs of the tests, 33 minutes versus 9 minutes. So again, I would say, lots of other factors can impact this, but it still looks like we're getting a 50% bump just by saying, don't send background jobs into the background if you're already running in the background. The other thing that's happening with the background jobs is every time we put something in a queue and take it out, we usually save it to disk and reload it each time a job calls a job or a service calls a job. Each of those saves and reloads is taking time. I haven't had time to actually untangle all of that, but I think if we actually said, hey, we already have this thing in memory and we can keep it in memory, we could even improve the performance. So here's my learnings. For older Hyku apps, probably make sure you have that good job priority configuration and make sure that all the jobs that run are listed in there so that they all have a same priority. Two, good jobs or Sidekick, make sure that you've actually tuned to the environment you're running in. So I have an 8 CPU laptop. I wasn't actually using all of those. I could probably get even better performance by just tuning to that. One of the things that I ran into personally was that I'm used to using Hyrax-based apps, which all default to using Sidekick. That's the default queuing system in the Hyrax generators. Hyku uses Good Job. As a community, it might make sense for us to standardize on one of those and make sure that Hyrax and Hyku use both of those. It seems like there's more recent experience around Good Job, so maybe standardize there. Talked about those two. The performance patch that I made seems safe and seems like something we could do. A longer term performance fix would be really to look at all of those jobs, untangle jobs, calling services, calling jobs, calling services, and see if we couldn't keep the objects persisted in memory, not have to save them to disk, and call without having to override the perform later method and just make sure that we're calling all these. So that's what I learned and what I think. That's my 7 minutes. And if there's questions, I'm happy to answer any.